Hello students of Design of Concrete Structures, CE703, lesson number 2. Here we will be discussing materials. The first of the material is concrete and the other one is the reinforcement, that means steel. In concrete we have several materials which combines and the concrete is made. First of all, we will talk about cement. Cement is a adhesive and cohesive properties. Cement has adhesive and cohesive properties necessary to bond in aggregates into a solid mass of adequate strength. We know that cement is a binding material. That's all. Then in general we will call it as binding material, hydraulic cement. The raw material of cement is limestone and clay. Its chemical name is calcium oxide, and clays or shale which furnish silicon dioxide and aluminate. These are ground and blended and fused to clinkers. That means heated in a clinker in a kiln heated to clinkers in a kiln and cooled. Gypsum and additional untreated limestone are added and the mixture is ground to the required fineness. That means first of all we have to take raw material like limestone and clay, and these will be ground together and in a kiln it will be heated up to fusion, and after that fusion is cooled, and then gypsum and additional limestone is some additional limestone is added and ground it to required powder or furnace. Then it will become cement, and with water coming on it, the reaction with hydraulic water, it will react, and ultimately they will be hardened to become with aggregate to become concrete. And now we will talk about aggregates. In our country there are two types of aggregate. One is stone aggregate and the other is brick aggregate. Stone is a natural material which comes as boulders or pebbles, which is available in the riverbed or near the hills. These are, if it is a big size, this is cast to certain size which will fit into the forms and will become coarse aggregate. And now in our country we use another type of aggregate, that is brick aggregate. We crush the overmade bricks into small sizes and sift according to our necessity, and we use that as aggregate, coarse aggregate. And sand is the major fine aggregate, and this is available in our country and in most of the countries. Both these aggregates, stone aggregate or brick aggregate or sand, is available abundantly, and in natural form these are found. These are picked up and used as fine aggregate for concrete. So we have two types of aggregate. One is the coarse aggregate, another is fine aggregate. Coarse aggregate is made from or obtained from stones, and brick aggregate is overburnt brick. Big jama bricks are crushed to required sizes, and that becomes the aggregate, coarse aggregate. Here we should mention one thing, that the size of the coarse aggregate. If the size of the coarse aggregate remains bigger, then it will not pass through the gap of the reinforcing bars. And if the slab thickness is smaller, then in that case we need smaller coarse aggregate, that is 1/3 of the slab thickness. The maximum size of coarse aggregate should not be more than 1/3 of the slab thickness, or 1/5 of the form, the size. That is, if structure size is 5 inches, then maximum size of coarse aggregate will be 1 inch. And there is another requirement for the size of the coarse aggregate, that is, it should pass through the gap between reinforcing steels. and in beams especially, the reinforcing steels are very close, and that's why the aggregate size should be properly chosen, that the aggregate size should be 3/4 of the gap between the bars. That is the requirement, and it should be well graded. That means there must be present for all sizes, not one size only, and the gap. Therefore, the graded aggregate, you should call it a graded aggregate, and if we draw the gradation curve, we should form an S curve. That is the requirement for gradation of aggregate. And in concrete, cement concrete, normally mass concrete will have a weight of 140 to 152. On the average, we take it as 145. This weight will be required for while we will be calculating the weight for the structures when we will be going to the force system of the structure. Properties in compression for concrete. Figure 2.1 shows a typical stress strain curve for normal weight concrete, and there on the left side is the compressive stress FC in KSI, and in the horizontal, the base horizontal scale, that is strain. And the right hand side is given MPa. You can see the nature of this compression curve, and one thing you should realize that the strain in the concrete at near failure or maximum strain, that is at the peak of the compressive strength, is 0.003. This 0.003 strain will be required while we will be going for the design of beams and developing the formulas or relations for the structural design of concrete. So you must remember that the strain on the average for all compressive strength steel concrete is 0.003. This is a point to be noted and memorized for your life, for the whole of your life. And therefore, you must look into this figure 2.1, and try to understand that the 0.003 point will be coming out this value frequently. Then we'll talk about steel. You know, the reinforcing steel are available in the market for different strength, like 40 KSI, 50 KSI, 60 KSI, 75, and like that. Nowadays 50 KSI steel is not available, though 40 is also not preferred. Nowadays 60 and above steel, so that we can combine these two materials together to treat it as a single material. The one major thing is the thermal expansion coefficients. It is noted that the thermal expansion coefficient of steel is 6.5, but for concrete is very close to that, that is 5.5 into 10 to the power 6 per degree Fahrenheit. It's a very convenient similarity for these two materials, that they will act simultaneously and combinedly. This 6.5 and 5.5 expansion is very close. That's why when it will be heated, the expansion of one will not be far away from the expansion of the other one, or contraction of the one will not be far away from the contraction of the other. That's why they will remain altogether intact. While the corrosion resistance of bare steel is poor, concrete helps in the concrete that surrounds the steel reinforcement provides excellent corrosion protection. This is another advantage of these two materials to be used simultaneously, but in one structure or one unit. The corrosion problem will be protected by concrete coverage. the fire resistance of concrete is much more than the fire resistance of steel. As the steel will be covered with fire concrete, the fire will, the steel will not be will not expand so much as is expected if it was exposed without any coverage. That's why a thick layer of concrete will save the expansion, and then the two material will remain as one material. They will not separate. If one is if the expansion for one is very close to the expansion of another one, they will not separate and will remain as intact material. These three are the advantageous point for these two materials to be combined to perform as one material. Yes. About reinforcing bar, there are several sizes available in the market. It is 3/8 inch to 1/3 inch is for normal building and normal structure. These are the sizes available in the market, and these nowadays the reinforcing bars are deformed, and in figure the deformations, the separate type of deformations are shown in the figure, and you can see in the market also that there are different deformations for steel. Normal. Now we will talk about the grades and strength. About the steel material has some strength which is in KSI. Normally, very low strength steel is 40 KSI, and there are several type of this steel grading from 50, 60, 70, 75 like that up to nowadays. 60 KSI steel is preferred, and 50 KSI steel is not available, and in very low cases, very small structures, 40 KSI steels can be used, and up to 70, 75. Nowadays Bangladesh, there is a grade 72 that comes from the MK system. That's why that is 72. Otherwise, in APS system 40, 50, 60, 70 like that, the grades are like that. In testing, while we test this steel bars, then we will find a shape like next figure. The shapes of this stress strain curve is given in next pages. In A, the strain is 0.001, and in A graph, the scale is smaller. In B graph, this is expanded. Some part of this is expanded to that one. That's why that's this. Here, the modulus velocity of all grades of steel is 29 into 10 to the power 6 psi. This you have to remember for your life, and this will be used everywhere, anywhere. This modulus of velocity, which is written in the previous page, that is modulus velocity is 29 into 10 to the power 6 KSI for all grades of steel. This is an important thing to be noted, and you have learned this modulus velocity and the secession curve in your strength of materials lab in elaborate form. That's why we will be using this as values taken directly from this memory or from the text, and we will use this 60 grade or 70 grade or 50 grade, and modulus velocity as 29 into 10 to the power 6 psi. This much we should be remembering at this stage about steel, and on page 11 we have written 4 points here. Number 1 point is this: internal forces such as bending, moment, shear force, and normal and shear stresses at any section of a member are in equilibrium with the effect of the external loads at that section. This proposition is not an assumption, but actually it is like this. The strain in embedded reinforcing bar is the same as that of the surrounding concrete. It happens due to this bonding between these two together. And in the cross section, prior to loading, after loading, the cross section remains plain. This is another proposition. In view of the fact that the tensile strength of concrete is only a small fraction of its, normally the tensile strength of concrete is less. That's why in tension zone the concrete will not take any stress, and there will be some cracks which is negligible, and that's why these two materials can be used as a single one for construction and structures. This is for today.